Today we are going to study analyzing algorithms, an essential topic in computer science. This lecture will help you understand how we measure the performance and efficiency of an algorithm in a simple way. So, what is an algorithm analysis? Algorithm analysis is the process of evaluating the performance and efficiency of an algorithm. It helps us to determine how much time an algorithm will take and how much memory an algorithm will use. Algorithm analysis helps us to choose the most efficient solution. Now the question is, why do we analyze the algorithms? We analyze the algorithms for three main reasons. First is to compare the algorithms. Sometimes multiple algorithms solve the same problem. Algorithm analysis helps us to compare them and choose the best one. If two routes reach the same destination, we choose the faster route. And second is to predict the performance on large inputs. An algorithm may work fine for small input sizes, but become very slow when the input size increases. For example, searching 10 names is easy, but searching 1 million names requires a better algorithm. Third is to identify the bottlenecks. Algorithm analysis helps us to find the bottlenecks, which are the parts of a program that slow everything down, like traffic at a narrow bridge. One slow point delays everything. There are two main types of an algorithm analysis. First one is the time complexity that tells us how execution time grows as the input size increases. We don't measure the time in seconds, we measure how time increases with the input size. Second is the space complexity that tells us how much memory an algorithm needs. For example, an algorithm that stores many values needs more memory than one that uses the fewer variables. Common cases. When analyzing algorithms, we consider three common cases. First one is the best case. Best case is the minimum time taken by an algorithm. For example, finding a number at the first position in a list. Second is the average case. Average case is the normal or expected performance, like finding a number somewhere in the middle. Third is the worst case. Worst case is the maximum time taken by an algorithm, like finding a number at the last position or not found at all. Most of the time, we focus on worst case analysis. Notations used in algorithm analysis. To represent the algorithm growth mathematically, we use the asymptotic notations, big O notations. It represents the upper bound of an algorithm and it describes the worst case performance. Omega notation represents the lower bound. It describes the best case performance. Theta. Theta notation represents the exact or tight bound. It describes the average behavior when the best and the worst cases are the same. So think of an algorithm analysis like the traveling. Best case is the empty road and the average case is like the normal traffic and the worst case is like heavy traffic. Let's revise quickly. Algorithm analysis checks the performance and efficiency. It helps to compare the algorithms. It predicts behavior for large inputs. It identifies the bottlenecks. Two types, time complexity and the space complexity. Three cases, best case, average case, and the worst case. Notations used, big O, omega, and the theta. I hope this lecture helped you clearly understand the analyzing algorithms. If you found this video helpful, please like, share, and subscribe. In the next lecture, we will study the asymptotic notations with examples. Thank you for watching.